Hello everyone. So today I'm going to cover another lead code hard level question, and this is my favorite question, I could say. Actually a very good question which will open up all your concepts, all your learnings you have done until now, everything you can apply in the single question, I mean. Actually very good question. So the question first says, uh, it is binary search plus a mixture of something, and that mixture will know as and when we move forward with this question. Okay, so the question says that the distance of a pair of integers a and b is defined as the absolute difference between a and b. Correct. The distance between two numbers is the absolute difference between them. Now we are given an integer array nums and one integer k. We have to return the kth smallest distance among all the pairs nums I and nums j, where I is less than j between 0 to n. Okay, so what does this mean? There could be three different pairs: 1 1, 1 6, and again 1 1. 6 1 is same. Okay, opposite way is same because anyways we have to find the absolute difference. So this is 0, this is 5, and this is again 0. So it has been asked that we have to find the kth smallest distance among all the pairs nums I and nums j. So 1 6 1 1 6 1. Sorry, 6 1. 1 6 1 1 and 6 1. 6 1 should be the last pair, not, and 1 1 also. 1 6 1 1 6 1. That's it. 1 6 1 1 6 1. 1 6 1 1 6 1. Another time 1 1 will not be there. Okay. Fine. So this three are the pairs. So the third smallest distance is 5. First 0, second 5, third 5. So third smallest distance is 5. So the answer should be 5. Now we have to return that kth smallest distance. So from the kth smallest, we get a quick idea that okay, we have to use binary search. Cool. But again, this nums array is not sorted. Okay. Does that means anything? Does that applies? No, because we have to find that if mid is the smallest distance, if mid is kth smallest distance among all pairs. If yes, R is mid, else L is mid plus 1. Okay, now the question arises is to find if mid is kth smallest distance among all pairs. So we need to find, so the main question is we need to find all pairs with distance less than or equal to mid. So the question says we need to find all pairs with distance less than or equal to mid, but the distance of that pairs should be less than or equal to mid. Correct. I hope you got. And that count, that number of pairs, that count should be greater than or equal to k. So we need to count. We need to not just find, we need to count all pairs with distance less than or equal to mid. Okay. Now how we will find? How we will count the distance less than or equal to mid between pairs? This is the pairs kind of question. We have to find for pairs. So let's say if I choose 1, then how many I can pair up with 1? How will I find that? Okay, what if I sort this? Uh, let's say I've sorted this. And now I have to find the number of pairs with this distance. Now we have done a similar kind of thing, at least at most k kind of things in sliding window. So there it's like the product of the subarray should be less than or equal to k, at most k, or at max k, or at least k. Okay, those type of questions we have done. This is at most mid. Okay, distance between pair should be at most mid. So less than or equal to mid. Okay, that is the original question. That it should be at most mid, maximum mid, and we have to count such a number of pairs. So there also we do count the number of subarrays. We have done those type of questions where we are counting the number of subarrays. Okay. Now let's take a bigger example. I'll Okay, let's say we have this array 1, 1, 2, 4, 5, 6, 6. I'm already sorting it and making it visible to you. Why sorting? Because in sliding window, if we have found the pairs between 5 and 1, then all such pairs in between should also lie. So there is one condition that the array should be sorted for this type of questions, where if we have found that between 5 and 1, we have find the distance as 4, then all the in between should will also be 4. Then we can count it directly. There we are counting j minus I plus 1 to count the number of pairs or number of sub arrays. Okay, because j minus I plus 1 is the length, actually the length, but not the length, total number of sub arrays also. Only one, 1, 1, 1, 1, 2, 1, 1, 2, 4. Kind of like this. Total number of sub arrays also. So this should be sorted. Now let's say I have found this, my I is here and my j is here. Okay. I have to find the distance, fourth smallest distance, and I am at mid is equal to, let's say I have considered the L should be 0. Okay. Something minimum distance I could find between the pairs is 0, and maximum distance could be 6 minus 1, which is 5. Okay, so my mid is 3 as of now. Okay, so I'll find how many pairs have distance less than or equal to 3. So initially my I and j both are at same point. So 1 minus 1 is 0. This is one first. 1 minus 1 is 0. Okay, which is less than or equal to 3. So I have to consider this pair. Before I start, let me just make you familiar with the template. But again, it will be very efficient if you go and watch that video of at least at most k uh, in the sliding window playlist. I could put that over the iCard over here. But still, let me just go through the template. So it's like we have to find something whose distance or sum or something at most k. Okay, then we'll do if that condition less than equal to k, at most k means less than equal to k. Then we will count the number of pairs. So number of pairs will be j minus I plus 1. Okay, number of pairs or number of subarrays or whatsoever. Otherwise, while that condition becomes greater than k, so while that condition is not satisfying and I is less than equal to j, we will slide the window. So we will do the opposite of calculation. We will slide the window. As of now, we will do just I plus plus, and we will do count minus equal to. Whatever counts we have added, we'll subtract from this point. Okay, and after coming from the while loop, we will again check if the condition has become less than equal to k. If it is again satisfying, then we will add, otherwise those counts, otherwise not. So this is the basic template which we follow. Again, let's move to our question which says that 1, 1, 2, 4, 5, 6 and 6, and your k is fourth smallest distance, and you have found first mid as 3. So you need to find the number of pairs with distance less than or equal to 3. So first you are at here, 1 minus 1 is 0. But total number of pairs will be, for pairs, the count should not be j minus I plus 1. The subarrays should be j minus I plus 1. Okay. If you are at here, j is 0, I is 0 plus 1. Only one subarray which is containing only one element. But for pairs, at least two elements needed. Okay. No, at least only two elements needed. So it will be j minus I only. It will be j minus I only. So j minus I. J minus I is nothing but 0 in this case. So this wouldn't be considered. We'll do j plus plus. Now I'm at here. 1 minus 1, again 0, which is less than or equal to 3. So I'll count the number of pairs is 1. Okay, which pair? This. Now I am at 2. Okay. Again, j minus I is 1, which is less than equal to 3. So my count will be added with j minus I, which is what? J is at 2, I is at 0, 2. Two pairs I am adding. Which two pairs? As of now, it's 1, 1. I'm adding 1, 2. I'm adding this one and this 2, and this one and this 2 also. So this two pairs I am adding. Okay. This and this. This two pairs I am adding. So now my answer is, total count is 3. 1, 1, 1, 2 and 1, 2. Why two 1, 2s? One this one and 2 and this one and 2. Now I'm at 4. 4 minus 1 is again less than or equal to 3. Cool. So 4 minus 1 is again less than equal to 3. So now I have to find the total number of pairs from this I to this j, which has distance less than equal to 3. All those, how many? Again j minus I. How many? 1, 2, 3. 3 different pairs I can add. So count plus equal to 3, which will be this 1 and 4, this 1 and 4, and this 2 and 4. 1, 4, 1, 4, 2, 4. So your count has become 3 plus 3, 6 until now. Okay. Now you are at 5. Now it won't satisfy. 5 minus 1 is greater than 3, greater than or equal to 3. Okay. It's not less than or equal to 3, it's greater than 3. So now this wouldn't satisfy. So now what you will do? This 5 and this 1 is not satisfying. So what we can do is we can do I plus plus. We can do I plus plus. Okay. 5. No, we haven't added those counts in our original answer. So will do is just I plus plus. Yes. Okay. We haven't added those counts, so we'll do I plus plus. We haven't done any calculations like summations or products or such kind of things. So no need of doing opposite of those calculations. So again we'll do I plus plus. Now I'm at 1, this one. Again 5 minus 1 is 4, which is greater than 3. No possible. We'll move my I to 1, this 2. 5 minus 2 is less than equal to 3. Now I'll make how many pairs? Two different pairs, because this is at index 5, this is at index 2. Sorry, this is at index 4 and this is at 2. So two pairs, 2, 5 and 4, 5. Again, I'll add those 2, 5 and 4, 5. So my count will be 8. Similar way. So then you will find the total number of subarrays, count pairs with distance at most mid. Why at most mid? Less than or equal to mid. I'm finding. So this is a mixture of sliding window, binary search, sorting also you have to do and understand why sorting is needed. If this is not sorted, we could not apply this. Okay, because this full logic is like if this is distance less than 3, then in between also should be less than equal to 3, depends on the sorted array only. So we have to sort it. I hope you have got it. Let's just quickly solve the question. Okay. So we need to find the distance of pairs and kth smallest distance we need to return. Okay. So I'll first sort this. Int L is 0. R should be maximum element. Maximum element minus minimum element. Okay. Fine. Now we have R minus L greater than 1. Mid needs to be L plus R minus L divided by 2. We'll consider if mid is the kth smallest distance. So if is possible with mid, nums and k, we'll do R as mid, else L as mid plus 1. Again, we'll first try for L because it's smallest. L mid and k, sorry, L nums and k. Then we will return L, otherwise we'll return R. Now your core logic lies in finding the is possible function. So is possible has mid, nums and k. Now we'll find count number of pairs that should be greater than equal to k. Okay, with distance less than equal to mid. We'll have two things, I and j, and n as this size. While j less than n, our sliding window template. If absolute difference between nums j minus nums I. No need of absolute also, because our j will always be greater than I only, as we have sorted. So we can write it as it is also. If nums j minus nums I is less than equal to mid, okay, then total number of pairs added will be j minus I. Otherwise, while nums j minus nums I is greater than mid and I less than equal to j, what we have to do? I plus plus just. So after coming out, if again nums j minus nums I is less than equal to mid, we'll do count plus equal to j minus I and j plus plus here also and here also. Okay, and then we will return this count should be greater than or equal to k for sure. Okay, let's see how is it working. But this is actually very good question. It's in my favorites. It's saved because I do like this question. A lot of templates, lot of logics, and lot of uh, different styles of techniques you have to use in the same question, and this could be asked in many companies. Okay, fine. I'll be coming with the such type of another lead code hard level questions which are actually very famous in the next video. So stay tuned for the next video, and if you're learning a lot out of this, do like, share, and subscribe with your friends. I'll be coming with the next video with the similar kind of Kate smallest, but now in the 1D area. Now almost 2D area we are done. This is also 1D, but those topics would be little familiar. You have heard it somewhere. Those type of such questions will be there in next video. Stay tuned. Stay safe. Until then, bye bye.